Okay, just to quickly talk you through question 3 and 4 from 2C. So question 3, you've got a stone and it's projected from a point above horizontal ground with speed 32 at an angle of 10 degrees below the horizontal. So that's probably what's going to confuse you. So if that's the horizontal, that's your angle in there. Okay, so the speed is working below, or it's being projected below the horizontal. So just be careful with that. You've been asked to find the height of the point of projection above the ground. On the diagram here, that's just going to be y, so we need to find y. So if you consider the motion vertically, it makes sense to take down as positive because the projectile is acting down the way. So resolving u, you're not going across the angle, you're going away from it. So if you're not going across, you're not using cos. So it's going to be u sine 10. Acceleration is acting in the right direction, downward, so it's 9.8, positive. The distance we're trying to find is y, and we're told that it takes 2.5 seconds to reach the ground. So all you have to do then is substitute in d s equals ut plus a half at squared, and your correct answer falls out. Now B is horribly worded, but it reads, find the distance. Hold on a second, let me rub this out. Okay, sorry, let me go again. So find the distance from the point on the ground vertically below the point of projection, that's that point, to the point where the stone reaches the ground, and that's that point. So what it's basically just saying is find x in my diagram. And in 4b, it uses the word range, and that's what the range is. Okay, so how would you find x? Well, across the way, there's no acceleration, it's constant velocity. So resolving horizontally, it'd be u cos 10 times 2.5. So substituting into speed, distance, time, you'll get your correct answer down there. Okay. Moving on to question 4 now. So question 4, a projectile is launched from a point on horizontal ground with speed 150 at an angle of 10 degrees above the horizontal. So that's your 10 degrees in there. Okay, you've been asked to find, I think you're okay with this, the time the projectile takes to reach its highest point. So when you consider the vertical direction, the particle reaches its max height at v equals 0, okay? So v equals 0, so that's why I wrote v equals 0 there. Taken up as positive, so acceleration is minus 9.8. And when you resolve the initial velocity, it's away from the angle, so it'll be 150 sine 10. You're finding the time to get the greatest height, so v equals u plus at, and I think you're okay with this one. The time was 2.66. Now part B, you've been asked to find the range. The range is just this distance here to here. It's the displacement in the horizontal direction. Now, you know that there's no acceleration in the horizontal plane. There's no forces acting, and it's just constant velocity. So if you're trying to find that distance, you clearly need to know the time. So from part A, if the particle takes from here to here, what did we say? It was about 2.66 seconds. Store that into your calculator. If that's 2.66 seconds to there, well, this is symmetrical, so it's another 2.66 seconds to get to there. So the total flight time is just double that, and that's what I've wrote here. So using symmetry, the flight time will be double that number, which is 5.32. So now that we have the time and we have the speed in the horizontal direction, so resolving 150 cos 10, and multiply that by 5.32, and you get your answer of 785. And the answers that are given have been rounded to 2 significant figures.